Officer Jordan, who is riding a motorcycle identical to Officer Sarah's, waits 15 seconds, then starts from rest and accelerates to 70 meters per second in 6 seconds in an attempt to back up Sarah. How far ahead will Sarah be when Jordan reaches top speed? Alright, so just to be clear, guys, if you haven't seen part 1 of this video, go back to my YouTube channel, take a look at part 1. You're not really going to understand what I was just asking in part 2 if you haven't already seen part 1. One thing I want to point out about this problem is that it's rather conceptual compared to the rest of the problems that we've been doing on YouTube. So I drew a picture. I think the picture is going to be really important in solving this problem. So here's what we know. From part 1, we know Sarah takes 6 seconds to go 210 meters, to go from 0 to 70. All right? Now at that point, Sarah's going to go 6 seconds to go from 0 to 70. Then she's going to continue to travel at a constant velocity of 70 meters per second indefinitely, all right, until we say stop. So now what we're going to do is we're going to look at Officer Jordan. Well, according to the problem, Officer Jordan waits 15 seconds, then starts behind Sarah. So Sarah's going, chugging along, chugging along, chugging along, chugging along. 15 seconds later, Officer Jordan starts up. Starts up. And then it says, how far ahead is Officer Sarah when Officer Jordan has reached her top speed? Now, because they're driving identical motorcycles, we know that this part of Officer Sarah's journey is going to be identical to this part of Officer Jordan's journey. In 6 seconds, she's going to travel 210 meters and go from rest to 70 meters per second. Just like Sarah did, that's what Jordan's going to do. The only difference is, now I kind of put this on the time axis. This is from the beginning through the first 6 seconds of the problem. This is from t equals 15 seconds after Sarah started, to t equals 21, those 6 seconds. So then the question is, way out here, after Officer Sarah has been traveling for 21 seconds, how far ahead is she? If you take a look at this diagram, I think you realize that this problem is not so bad. We know this distance is 210 meters. We know this distance is 210 meters. We really just need to know how far ahead Sarah is. She's moving at a constant velocity of 70 meters per second. And if she's going from t equals 6 to t equals 21, she's going to be doing that for 15 seconds. So what you can see here is we have, if you want to still write down your given, we have a constant velocity of 70 meters per second, and she's going to be traveling 70 meters per second for 15 seconds. And then the question now becomes, how far is she going to go? That's what we really need to know. So I'm just going to plug that into our formula. We know velocity is equal to displacement over time. We're going to move the delta t over to solve for delta x. And then by just punching in the numbers here, you get 15 times 70. I believe if you put that in your calculator, you should get 1,050 meters. And so that goes right here. And that is how far ahead Sarah is when Jordan gets to her top speed. Like I said, not a lot of math with this problem. This is the perfect example of a type of problem where you need to have the picture. I think once you see the picture, the rest of it makes a lot of sense. Thanks a lot for watching. I hope it helped.